You should have already turned in Monday 1 through 8, Tuesday 9 through 12, yesterday 13 to 17. Today we're doing 18 to 20. Okay. Now 18 is about solving equations. So let's kind of just classify what kind of equation each one is. If you look at A, B, C, D, E, A, B, C, D, and E. Those are just standard solve for X sort of equations, okay? Now, some are a little bit harder than others, but, get the X's to one side, numbers to the other side, do your thing. Just be careful of your order of operations. The ones I want to focus on are the fractional ones, D, E, and F. I assume you can do A, B, and C on your own, so that's your responsibility, but let's talk about D, E, and F for a moment. So let's start out with D. Now, as you move, getting ready for hopefully taking a calculus class someday in your future, solving equations quickly and efficiently is really important. In a calculus class, sometimes the algebra itself leads you to just a standard old good old equation and you got to solve it. So the tricks I can give you, I'll try to, as we go through this class, I've kind of given you some tricks. But when I look at an equation like D, I would say I don't need to deal with fractions. And so the way that we're going to get rid of that for D, my suggestion would be anytime you have a fractional equation, and this is only with equations, not expressions, multiply through by the common denominator. Then you don't have to deal with fractions again until possibly the last step. And so it makes everything just so much nicer. So I'm going to do this over on the side here. So if we multiply every single thing by 15, now technically that's 15 over 1. So only the tops of our fractions are going to be multiplied by 15. So the first fraction, we would get 30x divided by 5, which is 6x. 15 times 5 for the next thing, that would be 75x. And our last piece there, 4 times 15 is 60, divided by 3 is 20. So that equals 20. Now look how much easier of an equation we immediately get by doing that trick. Because equations, we know you're allowed to multiply it through by anything you want, divide through by anything you want. So why not? I've always done that as a trick for a first step in a fractional equation. And so now think about this equation. So much easier. 75 plus 6 is 81. Divide both sides by 81. We have solved it. We didn't even have to use a calculator. It becomes just so much easier to do that. Now, if 20 over 81 reduces down, please reduce your fraction, your final answer as much as possible. But it makes us not have to deal with fractions again until the end. And so I've always done that trick when it comes to a equation containing fractions. So when we look at E, I'm going to do the same thing. The only denominators in the problem are 5, 2, and 10. So just multiply by the common denominator of 10. It'll take care of all those fractions. You don't have to deal with them again until the end of your work. So for E, if I multiply everything through by 10, the first equation, or the first term, I would get 10x divided by 5, which is 2x. The second term, I would get 10x divided by 2, which is 5x. Don't forget to bring that negative along for the ride. After the equal sign, we got that 3. 3 times 10 is 30. And then we have, it would be 30x divided by 10, which is plus 3x. And again, it just becomes just a nicer equation to deal with right off the bat. Okay. So now let's just go ahead and solve it. We're going to take the x's to one side, numbers to the other, good old equations. And so we get negative 3x equals 30 plus 3x. If you subtract 3x from both sides, you get negative 6x equals 30. Divide off that negative 6, you get x equals negative 5. And so very simple, very nice. Now, if we move on to F, we can do that same technique, but one great thing about F is what's called a proportion. A proportion can be solved by cross multiplication. You guys want to tend to apply cross multiplication to things. And many times you can't. But this is one time where we can just cross multiply. But here's the trick. Please make sure that you surround any multiple term piece by parentheses so you remember to distribute properly. Otherwise, you might forget. So if we cross multiply for f, because that's the best way, I think the quickest way to solve a proportion, we get 2 times 10x plus 3 is equal to 1 times 5x plus 6. Now, you don't have to write the 1 times, but I'm just kind of clarifying what happened. You could have even the 2 there just distributed. That's okay with me. You could have just distributed right off the bat. But we get 20x plus 6 equals 5x plus 6. If you subtract 6 from both sides, you get 20x equals 5x. So you get that 15x equals 0. So x is equal to 0. Now, anytime you have an x in your denominator, you should always go back and plug that back into the original. And if you plug it back into the original, it better not give you a 0 denominator. It does not. It gives you a 6 in this denominator, and 6 is okay. As long as you don't get a 0 denominator when plugged into the original, you're good to go. That would be your final answer. Okay. Now, G is a little bit different, but not completely. Here's the only problem with G. The only problem with G is it still has fractions, so we can take care of it the same way, multiply through by the common denominator. But if you'll notice, we do have an x denominator, so remember that denominator is not allowed to equal 0. So if we would get a 0 as an answer, we would throw that one out, because that would make that denominator 0, which would muck up the whole entire mess. So make sure to remember that. But you can still do the same trick. Multiply everything through by that common denominator. Nice things are going to happen. So let's go ahead and do G. I'm going to do it right here. I'll make it small for a minute. And as I multiply through by x, I get 15 minus 4x equals 6 plus 3x. I do get a much, much nicer thing by multiplying everything through by x. But you got to keep in mind, x is not allowed to equal 0. That'll screw everything up, okay? But that's just an equation. Move the x's to one side, numbers to the other. You decide what side to put them on. Okay, doesn't matter. To make them positive, why not move the x's to the right? Let's add 4x to both sides. Let's subtract 6 from both sides. We get that 7x is equal to 9. So we do get a fractional answer, and that's common if you started out with fractions, that you do come back to them. That's pretty common when it's all said and done. And so we get 9 divided by 7. Now, it's a little weird to plug that in, but we didn't get an answer of 0, but you could plug it in to check your work. You could plug any of these in to check your work for your answer. So for 18, you're going to do A, B, and C. Now I would like to move on to H. Now, H is the only one that is a quadratic. The most effective way to solve a quadratic is to factor it if possible. If it's not factorable, or maybe if you don't like factoring, you could always use the quadratic formula. That always solves a quadratic. So feel free to either factor or use the quadratic formula. It doesn't hurt me one way or the other. You decide. What's great about this one is it is a factorable quantity. So it does make life nice. We can just break it apart. It would be x minus 5 and x plus 1. Now, why is it x minus 5 and x plus 1? Well, negative 5 times 1 is the negative 5 we see here. So these numbers have to multiply to give you what you see there. So it does. But they have to add up to the center value. So negative 5 plus 1 is negative 4. So that's good. Now, once it's factorable and you've factored it, the next phase is just to split it apart, solve it individually. Because the zero product property said, well, the first one could have been the thing that gave you the 0, or the second one. It doesn't matter. Just use it. So this one gives us a value of positive 5. This one gives us a value of negative 1. So quadratics very often you will get 2 solutions, okay? And again, if it's not factorable, you're forced to use the quadratic formula, but if it's factorable, that's the most efficient way to solve those, okay? So please finish A, B, and C once we have done talking through the rest, okay? Any questions about the ones we have done for problem 18? Okay, so now I would like to do 19 and 20 with you, and let's talk about those. Now, for 19, an absolute value inequality, we had touched upon this year, but I just want to remind you the rules of that. The most effective way to do an absolute value less than is to take off the absolute value and stick the negative portion on the other side. It's a between. The reason it's a between is it's an intersection. I am stuck between -3 and +3. Remember, our absolute value has a positive case and a negative case. Absolute value less than, you just stick the negative case directly on it. It's the easiest of our absolute values to solve because of the fact we can just attach it to it. And then it just becomes kind of a 3-part equation. Whatever you do to the middle to get your x by itself, you do to everything. So I'm going to add 7 to all those pieces. I get 4 is less than 2x, which is less than 10. So now 2x is stuck between 4 and 10. And then you just divide off the 2. The only time you have to worry about division in an absolute value, or I'm sorry, an inequality, is if it is a negative, but we're dividing by a positive, so it doesn't mess with anything. So we get 2 is less than x is less than 5. So if we were to put that into interval notation, x would be any values between 2 and 5, not including 2 and 5, because 2 and 5 are those border values which are not included since we didn't have an equal to. Now they said to put your number or your answer on a number line, so let's go ahead and do that. These would both be open circles because of the fact we did not have equality in there. If you got the equal to symbol, remember coloring your dot. If you don't, leave it open. And then the less than inequality is always, or most of the time, a chunk from here to here. The greater than ones, usually the pieces going outward. Okay, so that is our answer to 19. Do we have any questions about 19 before we move on to 20? Anybody have any questions about 19? Okay, so there's 19. Last one we're going to do is 20. Then you'll have the rest of the class to get yourself caught up with the things that are going to be on the third 9 weeks. So let's do 20. So they say to solve it and then write your solution in interval notation. Okay. So to solve an inequality, just treat it like an equation. Just remember, if you multiply or divide by a negative, you're going to turn that symbol. That's the only main thing to remember. So subtract 2 from both sides. You get that negative 5x is greater than or equal to 13. When you divide through by that negative 5, what I like to do is kind of note the symbol. So the next time I write it, because I tend to forget, you guys know I make those silly mistakes. That kind of is a little reminder, hey, I divided by negative, so I got to turn that symbol. So I get x is less than or equal to negative 13 over 5. So if we were to graph it, negative 13 over 5 is negative 2.6, if that helps you for any reason. We would have a closed circle at that spot, and then we want to shade everything to the left. Now, the reason I like to graph it is because that really will help you to clarify the interval notation. So the interval notation, it would be the x's from negative infinity to negative 13/5. I need to include it in a bracket because the original had an equal to on it. Remember, your infinity or negative infinity never has a bracket. You can't really get to a location, so always put a parenthesis on that. So again, your job is to please finish out 18 A, B, and C, and the rest of this, please turn in 18 through 20. So at this time, you should have, so please go into Google Classroom. You should have the 6A notes turned in. You should have the 6A homework number 1 and 2. You should have the 6B transformations. You should have the December Achieve. You should have the algebra review from Monday, which was 1 to 8. Tuesday was 9 to 12. Wednesday was 13 to 17. Today is 18 to 20. Those are all going on the third 9 weeks. Many of you have not turned all of those things in. You will see in Google Classroom that the due dates for those are going to change to Monday at 8 a.m., but they're not. The original due dates hold. So if you turn them in late, you are going to get some partial credit, some credit removed. But for the purposes of everything, I have to, when I put them into Google Classroom, if it says that they were due during this 9 weeks, it'll mess everything up. So disregard the date it says and think about the date it originally was due. If you turn it in late, you'll get partial credit. So for the rest of class, any of these things you don't have turned in, do them. This weekend, any of these things you don't have done, do them, so that we can start off the third 9 weeks on a good foot, okay? And then next week we start trigonometry. So there you go.